Bismillahirrahmanirrahim. Our lesson of today is concerned about, still we are in chemistry, page 33. Page 33, chapter 2, classification of matter. And today, our subtopic is physical change. Physical change. A physical change is a change in the state or properties of matter without changing its chemical composition. If the examiner asks you, what is physical change? You will answer for the following. A physical change is a branch in the state or properties of matter without changing its chemical composition. Examples of physical changes are melting, freezing, or changing size or shaping. Physical changes which occur when the appearance of a substance changes, but chemically the substance is the same. It also occurs when substances are mixed or dissolved, such as mixing salt and water. A physical change is reversible change that does not involve changes in matter's chemical makeup or chemical properties. For example, common changes of state of matter are physical changes. For example, when a cubic butter is going to melt, so you have to put it in a banner, pancake there, the bun. Then after a minute, the cubic butter will melt. The butter melts. Come up with the ice cube. After a minute, when the ice stays in outside, the ice cube melts again. Then it will turn into water. Therefore, we are going to do an experiment. What change takes place when iron is magnetized? What change takes place when iron is magnetized? Material is iron nail. A magnet is still beams. So the procedure that we are going to take in: number one, get a large iron nail. Two, draw the iron nail to some steel beams to see if it attracts them. 3. Put one end of the magnet on the nail near the head. 4. Stroke the whole nail with the magnet 20 times. Stroke in one direction only as illustrated. Number 5. As illustrated. Number 5. Draw the nail again to some other beams. Observation. The observation is, what did you observe? Does the nail attract? Number 2. Does the nail attract the beams after the magnetization? Number 3. Does magnetization of the iron nail affect the composition of the nail? Number 4. What changes did you observe? Still we are in bit 33 to bit 34. Okay, let me go to bit 35. Conclusion. An iron or steel object can be magnetized by stroking it with a magnet, but does not affect its composition. Experiment. What kind of change happens when salt is dissolved in water? Is it reversible? An experiment 2. One an experiment we have ended there. There another one. Experiment. What kind of change happens when salt is dissolved in water? Is it reversible? Materials: clear plastic cup, scale, table salt, plastic spoon for stirring, measuring spoon. Procedure. The procedure that we are going to take in 1. Point 1. Put about 15 ml, about 1 tablespoon of salt into a clear plastic cup. Place the cup on a scale and find the weight of the cup and the salty record the weight. Fill the cup to about 1/3 full of hot tap water and stir until all the salty has dissolved. Using a permanent marker, draw a line at the level of the water and place the cup in the sun where it can remain undisturbed until the water evaporates. Check the cup daily. If you notice any changes, record your observations. When the water has completely evaporated, record your observations. Weigh the cup and the material in it. Record the weight. Therefore, observations. Number 1. Make a prediction. Hypothesis. What will happen to the salt when the water evaporates? 2. How is the weight of the cup after the water evaporated? Compare with the weight of the cup and the salt before the water was ended. Explain why. What is the material in the cup? Compare the size of the salt before and after dissolving it in water. Was your prediction correct? When the salt dissolved in the water, was it a chemical or a physical change? How do you know? Conclusion. Dissolving salt in water is a physical change because all of the salt was still there when the water evaporated and there was no new substance formed. Okay, 2.2. Bit 36. Have you ever seen a burning wood, pepper, charcoal, etc.? What did you see? Explain. Experiment. What happens if magnesium is burned in air? Material: magnesium ribbon, Bunsen burner, crucible, clay, triangle and tripod stand, chongis, balance. Procedure: 1. Take a piece of magnesium ribbon about 15 centimeter long and roll it into a tight coil. Number 2. Weigh an empty crucible with lid and record its mass. 3. Place the coil of magnesium ribbon into the crucible. Weigh the crucible, the lid, and magnesium. Then record this mass. Place the crucible on a bed clay triangle on a tripod stand and heat over Bunsen burner for 1 minute. 5. Carefully lift the lid slightly with tongs. Do not let any white smoke escape and replace the lid. This will prevent any loss of product. Number 6. Lift the lid periodically over 5 minutes to ensure an adequate supply of oxygen. 7. Let the crucible cool. When it is cool, weigh it. Record the mass of the crucible, lid, and the product. Observation. What did you observe? What did you observe? Conclusion. The burning of magnesium is a reaction between the metal magnesium and oxygen in the air. The magnesium will burst into flames as the air reaches it. A chemical change occurs, forming a new compound, magnesium oxide, with a new mass. Chemical properties are properties that. What is chemical properties are? Chemical properties are properties that are related to the reactions of substance that change its identity and new substance formed. If you asked what is